We chose to make our theme Atlanta United because we have all been to Atlanta United games at Mercedes-Benz Stadium, and we have a lot of fun watching and playing soccer together. Also, math is a universal language and soccer is a universal sport, so it's perfect for this project.
Alright, for our first question, we have the integral of negative 3x to the negative first times dx. So this is a fairly simple problem. The first thing we want to do is get rid of that negative exponent. So all we're going to do is rewrite it like this. So that negative 1 is turning into 1 over x. Next, what we could do is take out the negative 3 and put that in front of the integral. Like so. And this might look familiar. You can recall the natural log integral rule, which states that the integral of 1 over u du equals the natural log of the absolute value of u plus c. So we can see that this is in the same format as this. So all we have to do is rewrite it as negative 3 times the natural log of the absolute value of x plus c because it's indefinite. And that's all you have to do.
Okay, so the second problem is the integral of 5 over x times d of x. So you're going to use the natural log integral rule. So it's going to be 5, you're going to take the 5 out, integral 1 over x times d of x. And then since you're using the rule, it's going to be 5 times natural log of the absolute value of x times, or plus your c.
So question number 3 is the integral of negative 2 over x times dx. So we know that we have to use the natural log integral rule like the other two problems. So first we're going to take out the negative 2 so that it becomes negative 2 integral 1 over x times dx. And then we're going to apply the rule. So it's negative 2 times the natural log, the absolute value of x, plus c, because it's an indefinite integral.
Alright, number 4 is the integral of negative 16x over 2x squared minus 3 times dx. Now you can see that this problem is a little bit more complex. So in order to get it into the natural log integral rule form, we're going to want to do u substitution first. So u equals, you might wonder which value you want to set u equal to. And sometimes it's easier to use whatever value has the higher exponent. So in this case, it's going to be the denominator. So u equals 2x squared minus 3. From here, all we're going to do is take the derivative. So that's going to be du over dx equals 4x. Now our goal for this part is to get 4x, du and 4x equal to dx. So the first thing we're going to do is have 4x dx equal du. Then we're just going to swap that and have dx equal du over 4.
X.
Now we're going to be putting in these values. We're going to plug the starters back in, basically. So I'm going to go up here, and we're just going to have it as 16x over u, because we still haven't plugged u back in, times du over 4x. Now there is something that we can simplify here. You might see that we have 4x here, and we can also take a 4x out of here. So I'm just going to cross that out and write a 4 and just cross that out entirely. So next you can rewrite this as an integral, which is going to be 4 and then the integral of 1 over u times du, which is the form that we want it to be in. So we're going to process that integral, write it as 4 times the natural log, absolute value of u plus c. Remember that step because it's indefinite. And now all we have to do is plug u back in. So your final answer will be negative 4 times the natural log, absolute value of 2x squared minus 3 plus c.
Okay, so the next problem is number 5. It's the integral of negative 4x over x squared minus 5 dx. So your highest degree is x squared minus 5. So that's going to be your u. So you have u equals x squared minus 5. And then you're going to take the derivative, so it's going to be du over dx equals 2x. And then you're going to try and isolate the dx. So first you're going to want to multiply by dx, so it's 2x dx equals du. And then you can divide by 2x. So you'll have dx equals du over 2x. And now you want to plug it back in. You want to plug your u back into your original equation, and you want to multiply by du over 2x. So you have negative 4x over the u that you plugged in multiplied by du over 2x. And then you can simplify these two. And then you're going to have negative 2 outside the integral. And then you have 1 over u times du. And then you can do your natural log integral rule. So you have negative 2 ln, and then your absolute value of u plus c. And then you're going to plug your u back in from your original into here. So it's going to be negative 2 natural log of the absolute value of x squared minus 5 plus c.
So this problem is the integral of negative 2 secant x tan x times dx with the bounds of pi over 6 and 0. So first, what we're going to do is I'm going to use u substitution because I can see it clearer. So my u is going to be equal to x because there's an x all throughout, so it'll be easier to simplify. And then du over dx is equal to 1. So then dx is just equal to du over 1, which is just du. And then we're going to take the negative 2 and put it in front of the integral. And then, because we have the bounds, we're going to rewrite it like this. With the bounds outside of a bracket. So we can see that this is the same, but because the bounds are there, it makes it a definite integral. So then, we know if pi over 6, or if x is equal to pi over 6, then u is equal to pi over 6. And if x is equal to 0, then u is equal to 0. So, when we are plugging it back in, it's going to be, it's the rule that like secant tan x times dx is secant x plus c. So it'll be negative 2 secant x plus c because of the rule. So when you plug in u, it'll be negative 2 secant u plus c. And then you're going to plug in each of the bounds into u. So first we'll start with 0. So it'll be negative 2 secant, actually no, it's secant times pi over 6, secant of pi over 6, minus negative 2 secant of 0. So when you plug that into your calculator, you'll get negative 4 root 3 over 2, or no, root 3 over 3 plus 2. This is the bonus question.
Integral
Of e to the power of negative x to the 5th times negative 5x to the 4th dx. So, first we're going to use u sub, And usually when you're doing a problem with Euler's number, you want to take out what's in the exponent. So your u is going to be equal to negative x to the 5th. And then du over dx is the derivative. And that's negative 5x to the 4th. So then you want to get it in terms of dx. Okay, so now that you have it in terms of dx, you can plug u back into the equation. So it'll be the integral of Euler's number to the power of u. And then because it's Euler's number, it's also going to be your value for du over dx. So you're going to multiply negative 5x to the 4th. And then you're going to plug in for the dx as well. So times du over negative 5x to the 4th. So because we have the negative 5x to the 4th here and down here, you can cancel them out. So it'll be the integral of e power of u times du. And when you get it like this, it's equal to e power of u plus c. So now all you have to do is plug in your u again. So your answer will be e to the power of negative x to the 5th plus c, because it's an indefinite integral.
Okay, so our first question is the integral of negative 3x to the negative 1st times dx. So the first thing we want to do with this is get rid of that negative exponent. So all we're going to do is rewrite it like this. Then it's going to be times 1 over x dx, which gets rid of that negative exponent.